lesson is on factoring differences of squares. If you remember from a few sections ago, we looked at differences of squares, and the equation was a squared minus b squared equaled a minus b times a plus b. And in previous sections, we started out with the parentheses, and we FOILed out, and we got our answer of a squared minus b squared. So once again, in this section, we are going to go backwards. So we're going to start out with our a squared minus b squared, and we're going to end up with our set of parentheses. So let's do an example. All right, so if we start with m squared minus 81. All right, we're going to write these as something squared, so that'd be m squared minus something else squared. So the square root of 81 is 9. So m is going to be our a, and 9 is going to be our b. So when we write it in our parentheses, we have m minus 9 and m plus 9. Now if we FOIL this out, we can check to see if we get m squared minus 81 squared. So we get m squared plus 9m minus 9m minus 81. And this positive 9m minus 9m are going to cancel out, and we are left with m squared minus 81. So if you notice, in our parentheses, we have the same number and letter. The only thing that is different between the two parentheses is one is a positive 9 and one is a negative 9. So let's do another example. If we have 100s squared minus 25t squared. So one way we can do this is just like in the other one, write it as something squared minus something else squared. We see we have 10s and 5t. Okay. And then this would be our a, this would be our b. So we would have 10s minus 5t times 10s plus 5t. Once again, let's FOIL it out just to check and make sure we're right. 10s times 10s is 100s squared. Then we get plus 50st minus 50st minus 25t squared. Once again, our middle terms are going to cancel out, so we are left with 100s squared minus 25t squared. All right? So it's pretty simple. All you have to do is, inside your parentheses, find a and b, so the square root of whatever you start out with, and then just plug them into the parentheses. Another way you could solve this problem is by pulling out the greatest common factor first. So 100 and 25 have 25 in common. So if we pull out a 25, we are left with 4s squared minus t squared. So then once again, we're going to write it as 25 times, we're going to write it as something squared minus something else squared. The only thing that is different is we have this 25 out in front. So we're going to have 2s in the first one and t in the second. Then when we write our parentheses, we have our 25 still out front. Then we have our 2s minus t and our 2s plus t. Now if we factor this all out, we should once again get 100s squared minus 25t squared. So let's give it a shot. Let's leave the 25 out front for a little bit here and do our 2s times 2s. 4s squared. Then we get a plus 2st, a minus 2st, and a negative t squared. Once again, these middle terms cancel out. Now let's distribute our 25. 25 times 4 is 100 s squared minus 25 t squared, which, if we look back up here, is exactly what we started with. So there's more than one way to solve these problems. Alright, so let's do one more example. We have 1/9 x squared minus 4 over 25 y squared. So first thing we notice that is different about this one is they are fractions. So what we're going to do is we're going to keep them in fractions and not change them to decimals, because that's just going to create so much more work for us. So we're still going to write it as something squared minus something else squared. Now the tricky thing about fractions is we can't look at it right away and think of the square root. Maybe you can, but maybe you can't. So a trick is you can square root the top, which is going to be 1, then get the square root of the bottom, which is going to be 3, and then tag on our x. So let's see if 1/3 x is in fact the square root of 1/9 x squared. So if we have 1/3 x times 1/3 x, these x's are going to give us x squared, and then we multiply straight across with our fractions to get 1/9, which is exactly what we wanted in our parentheses. And then if we look at 4/25, the square root of 4 is going to be 2, and the square root of 25 is 5. Once again, let's check and make sure 2/5 times 2/5 gives us 4/25. 2 times 2 is 4. 5 times 5 is 25. So we just need to add our y on there. So once again, this is our a, this is our b, and now we just plug them into our parentheses. So the first one is a, which is 1/3 x, minus b, which is 2/5 y, times our second one, which is a, 1/3 x, plus 2/5 y. Once again, let's check it just to make sure we're right. 1/3 x times 1/3 x is 1/9 x squared. And then we're going to get 2/15 xy, and then a minus 2/15 xy, minus 4/25 y. Once again, middle terms cancel out, and we are left with exactly what we started with, 1/9 x squared minus 4/25 y. So the key to writing or factoring polynomials where there are difference of squares is to first break them down into a and b, so something squared minus something else squared, and then just plugging them into the formula. So whatever that a value is minus whatever the b value is, and then in the second parentheses you have whatever the a was plus whatever the b was. So since the signs are different and our a and b values are the same in both sets of parentheses, that means our middle terms here cancel out.